I record every lesson. Every lesson is available on Skyward. So if you get home and you forgot how to do this, get on YouTube. Check it out. Get on Skyward to find the link to YouTube. Please, please, please use this. Also, copies of the notes, copies of the worksheets, always on Skyward, right? Okay, here we go. So chapter 4 is all about triangles. Section 3 is about SSS and SAS. I bet you could guess what those mean. We'll get into it in just a second. So what I'm hoping by the end of today's lesson, you'll be able to look at two triangles and decide, are they congruent by using SSS or are they congruent by using SAS? So we probably should get to know what these are. Guys, any guesses? What do you think SSS stands for? Yes, did you look at it in your notes? It's side, side, side. Okay. It's so great because if you look at a triangle and this side has a match, and this side has a match, and this side has a match, guys, these two triangles have to be the exact same measurement. The sides are the same. Does that make sense logically that the angles will be forced to be the same? They're forced to be the same. So we can stop there. If you just check 3 sides on one, 3 sides on the other, and they match, you can say stop. These two are congruent. So shout it out. Guys, what does side MN match?
QR.
Perfect. All right, what about NP? Perfect. And then the last one, PM? Which one is it, QS or SQ? Let's do SQ. Let's be very careful about order in this chapter. So we check the sides. This matches this, this matches this, this matches this. So now we can say triangle MNP is congruent to, be careful, put it in order. Triangle what? QRS. If it asks for a Y, we can say because of side, side, side congruence. You check all sides, those two triangles will be forced to be congruent. Okay, so let's apply this one. Okay, here we go. It says prove the triangle DEF is congruent to triangle JKL. Because use that bottom space in your notebooks where it's wide open. This is where it finally clicked for me as a geometry student where I was like, oh, proofs kind of make sense now. It's just a step by step by step. I like proofs in this section because we can be really organized. Guys, proofs in this section are just 4 steps every time. So write down your statements, your 2-column proof, statements, reasons. Again, we can handle it with 4 steps every time. I'm going to teach you how to make an outline. Okay, looking at those 2 triangles, what postulate can we use to prove they're congruent? We just learned it. SSS. We can use side, side, side because every side has a match. So guys, for your proof, make an outline. You're going to need an S, an S, and an S. That's telling me I'm proving it by side, side, side. So this step needs to be a side, this step needs to be a side, and this step needs to be a side. It like organizes it for you. Does it matter which side you start with? No. Just start and then go for it. So I'm going to start with, how about DE? Guys, what matches side DE? Perfect. JK. All right, but what's the reason on this? Any guesses? Did we have to do any figuring out? We just looked at the picture. Do you agree with me? So if it was just on the picture, let's put given. They gave it to us. Okay, next one. If I said side EF, be careful. What would you say? Perfect. KL. What's the reason on this one? Given. It's on the picture. They gave it to us, right? Okay, let's finish with our last one. All right, I'm going to say FD. What matches FD? Perfect. LJ, how come? What's the reason? Oh, given. Okay, well, we're done. We proved it by side, side, side. So our last statement is going to be exactly what they asked us to prove right here. So we're going to say triangle DEF is congruent to triangle JKL. Okay, anybody know what the reason is? Our very last reason? It's side, side, side. That's why having that line is so great. So let's put side, 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 congruence. 4 steps every single time. Super nice. Yeah, we're doing great. Let's go to the top of the next page. Is it SAS? All right, what do you think SAS stands for? Side angle, side. Guys, it matters where that angle is. That's the biggest trick. Careful. In your notes, right here, circle this. Make it so obvious. It has to be the included angle. What kind of angle does it have to be? Included. Guys, SAS, that means the angle has to be sandwiched between the sides. So look at the example picture. Do you agree that this angle is sandwiched between them? Literally, it has to be between those two sides. If the angle was right here, it would not be SAS. If the angle was right here, that would not be SAS. Has to be the included angle. Literally has to be made up of those two congruent sides. I think SAS is like a sandwich, literally, with A in the middle. Angle has to be in the middle of the two sides. Be careful with that. It matters. Included angle. Okay. Let's fill this out. Okay, side PQ matches what? WX. Okay. What about angle Q? That's angle X. And then QS matches XY. So triangle PQS is congruent to WXY. And we could just say by side angle side congruent. So just two things today. We'll just do two things at once. We've got side, 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 and side angle side. So now we're just going to bounce back and forth between the two. Okay, this next proof, they did it in 3 steps. Let's just see if we can fill in their blanks. Okay, pause, look at your picture. Guys, can we use side, side, side on this one? No, so it's got to default to side angle side because those are the only two we have, right? So where's that angle? How come? They're vertical angles. So these two technically are congruent because they're vertical angles. Okay, let's fill out the proof, see if we can figure it out. So side TY matches, do you know? It's XY. Because it started outside to inside, outside to inside. And then SY matches, perfect, and that was just on the picture, so that was given. So they did both sides at once, that's okay. All right, how come angle 1 is congruent to angle 2? What's our reason? Vertical angles. Perfect, vertical angles. All right, so then they said, well, we're done. So triangle SYT is congruent to WYXY. Done. Side angle side congruent. Pretty nice proofs in this chapter. Yes?
So for this one, can you just have the angle as one thing?
Yeah, that's okay. That works. Okay, what's next? Okay, this one. Do you have enough room to do a proof? Oh, you've got plenty of room. Okay, let's do the 4-step proof. So get your statements and your reasons. Okay, again, you can always handle these if you're super organized in 4 steps. Okay, look at it. Is it going to be side, 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 or side angle side? Are you positive the angle's in the right spot? Okay, make sure you're checking that. So let's have number 1 be a side, number 2 be an angle, number 3 be a side. Okay, I'm just going to start with FT. Okay, so FT is congruent to what side? Yep. And that, why? What's the reason? Given it's on the picture. So nice. Okay, and now let's do our angle. Oh, be careful with this. Guys, I would be real nervous if you just put angle T is congruent to angle T. Because technically those are 2 different angles, so let's say them with 3 letters. So this would be angle FTG is congruent to angle, let me make sure it's the same order, RTS. Okay, Alec, what's the reason on that one? Let's just do given on this one. Yep. Stay with this, stay with this. Okay, next one, we've got number 3. I need another side. What one have I not done? How about GT? So GT is congruent to ST. Because what's the reason on that one? Just straight up given. We got everything from the picture. So last thing, we're done. We proved it. So triangle FGT is congruent to triangle RST. Again, I'm just getting that from right here. Okay, what's our reason on this one?
Side angle side.
Perfect. We're done. Side angle side congruent. That's it. You feeling okay about proofs in this chapter? You okay? Halloween. Okay, this one. Purposely put this one on here because of this symbol. Guys, will you make sure you emphasize this? And will you emphasize this one too? Guys, do those symbols mean the same thing? No, guaranteed some of you in this very class are going to look at these arrows and say that those are congruent. What do those arrows mean? That just means parallel. However, that's convenient because, let me color over this. We learned about parallel lines the entire chapter, last chapter. So if this line is parallel to this line, and you have this transversal cutting through it, can I get a hand in the air, and will you tell me what happens with this angle and this angle because those are parallel lines? Do you remember? One chapter ago, Ellie, do you remember? Alternate interior. Guys, what about alternate interior angles? They're congruent. So if we can add this in, those two are congruent to each other. So we've got a side from one triangle, an angle from one triangle. We need another side. Where is it? Okay, I'm going to make it obvious for you. Ready? This triangle right here in purple is congruent to this triangle in red. I'd say there's an overlap, and they use the same side. Can you see it? What are they both using? Both those triangles are using one, the transversal one. WZ, this one. So technically, if we had to write a proof, could we just say WZ is congruent to WZ? Like WZ from red is congruent to WZ from purple? You okay with that? Do you remember the reason why we can write this though? Oh, Tyler! Amazing. That's the reflexive property. That comes up, hint, hint, hint on your assignment. So they can always share stuff and you can always see they're congruent to each other. Yeah, you would need to do alternate interior too. So I don't know if we want to bother with the proof, but we would have like the 1, 2, 3, 4 steps, right? So the first step we could just say like WX is congruent to ZY. Second step are angles. We could say angle, how do I want to do it? XWZ is congruent to angles, I think I want to start with Y. YZW. This, Colton, to answer your question, that's where you would sneak in alternate interior angles for your reason. Yeah? And then you would just keep going with the proof. And exactly like right here, number 3 could be that reflexive property. You don't have to worry about writing that down, but keep it in the back of your head because it comes up on your assignment. Okay, let's skip the next. Oh no, let's do those next 2 problems. But again, those are proofs. So will you start them, please? Let me flip the page so you know what you're doing. Yeah, on your notes, start these 2. We'll go over them in just a little bit. While you're working on them, I'm going to get your scores. Okay, so we've got our proofs. 1, 2, 3, 4. Guys, what was your plan on the very first one? Was it SSS or SAS?
SAS.
SAS, I'm just going to put statements, reasons. So you did SAS. Okay. All right. So it looks like we could just say PT is congruent to ST. How come, guys? Given. All right. So this one, you would have to do angle PTQ is congruent to angle STR. Guys, what was your reason on the angles? I would say those are not given. It just has a 1 on there and a 2 on there. They're vertical angles. You need to step it up on that one. So vertical angles on that one. Okay, then the next one we need the other side. So QT is congruent to RT. Because what'd you put on your reason for that one? That one's definitely given because literally they have the symbols on there. So finish it. Triangle PTQ is congruent to triangle STR by side angle side. Congruent. Question, Ellen? No? Tyler, question? Mm-hmm. Okay, Tyler's question was, can we just do angle T congruent to angle T? I'm going to say no on that one, because that makes it look like it's the exact same angle, and these two are not the exact same. They are exact same as far as measurement, but orientation, they're not. Yeah, so be careful with that. I would say safest, always do an angle with 3 letters. Okay, what was your plan on number 3? SSS? All right, so here's the side. Here's the side. Oh, that's a good question. Back to this one. Angle 1 congruent to angle 2. Yeah, that's a good one. Do it. This side and this side. I only see 2 pairs of sides. Where's your third pair? Right here? This one? So that one is congruent. because of the reflexive property. So if that's like your very first, you could say GM is congruent to GM, reason, reflexive property. Then you okay finishing it? Sorry, Batman. Yeah? How many of you got the reflexive property in that one? Sweet, guys. Good job, good job. Okay, let's get your